who were good at math yesterday, and they tried to help me figure it out. And I think if I can figure out like what theorem to use, I can figure out the steps. But I couldn't
struggle with it.
I don't know, and I don't know if it was just like I was having a hard time like rewriting the triangles or something, but like I was having a hard time seeing which theorem I was supposed to use. I don't know if it was like the order or something.
Okay.
But I don't know.
Because it's not, like, I feel like it's similar.
It's the same as what we've been
Yeah.
doing. I know, that's what I'm like looking at the theorems and stuff, they look the same.
Okay.
I think it was just like, I think I rewrote the triangles maybe incorrectly. Like,
Yeah.
Yeah, they don't take it as serious.
Yeah.
I got an hour of extra sleep. I got 10 hours of sleep last night.
Oh my god.
I went to bed at 9 and I didn't get up till 7:15. What time? Oh my gosh, I got 10 hours of sleep.
Okay, can I have your homework, please?
Probably what Right?
Yeah, I did see one.
Yeah. That one.
Mr. Wolfie and Hannah. Lauren's not here today.
I have class,
I
okay?
had some Mountain Dew this morning too.
I will.
Oh, that's
We,
I don't really write that, but yeah.
usually we have a meeting,
I
I want to see that movie soon. Have you seen that movie, City of Bones yet?
No, I don't.
I really want to.
Did you do it yourself?
Yeah, I did it this morning, and then it looked really bad when I came to school. I just saw the front and I was like, ooh, that doesn't sound. So I just retaped it. Miss Breen.
What was the question? How do we write them?
Yeah, because I think I had to figure out how to read it. Because like I tried on this one and I couldn't figure out how to do that one. And so then I got it, well, I had to, then I did rewrite it and I just added in stuff that it was to. And so I was looking at it and I was trying to figure out like what order it went in. Yeah, I don't rewrite it. Well, I did rewrite it.
Well, this one makes sense.
Yeah, because they're angles.
Yeah, I did that.
Same here, you can do that. 90.
Oh, you don't have to rewrite that one either. Because like I tried to, but then it was.
Yeah, that'll just make it because honestly, it's hard.
You look so scared. It's okay. It's okay. It's okay. It's okay.
Did you use like the medium?
Like the H or whatever it was.
Yeah,
Lane.
I guess.
Not all of them, but sweet Dior. And then this was a bit confusing, but so it just shows you. You could just rewrite it.
You're very musical
That
today.
makes sense. Because you can just take it right out of here.
I'm not saying it's a bad
Hey,
thing.
get that. Is this recording? I think it is.
It's great. Oh, because this is a perpendicular line. This is AB's perpendicular.
Yeah, it's recorded.
Just because you wave your hand in front of it doesn't mean it's recording. It could
It
just be
also
open.
says right there, recording.
You could have just looked instead of waving your hand in front of it.
I felt like waving my hand in front.
Either way, you're gonna see it. Like, even if it's not recording, you're gonna see it. And you don't have to make that face either. Like, I'm not trying to be offensive towards you or anything. I'm just letting you know.
Oh my gosh.
you guys have.
7, you can take them out.
Number 7.
I'm not
We
sure.
really don't have time to do all of them. We only have 20 minutes. We have a final in like
The final.
5 class days. Over
Oh, yeah.
But I will do number 7. Alright. Angle G and angle H are right angles, EG is congruent to EH. Through that triangle EGF. EGF is congruent to triangle EHF. Okay, and so EF will obviously be the same on both. And you know that's about it, right? Angle G and H are right angles. Let's see why you have trouble with this one.
I had trouble with all of them.
Because they don't give you.
I think I did them wrong. It was kind of simple for me. I was like, this is way too easy.
Yeah, same here.
Yeah, kind
Like
of.
especially number 5. Like
Okay,
I
did
just
anybody get number 7?
No,
Yeah, I got them.
Sarah?
I said both the givens, and then EF is congruent to EF, and then,
Both the givens.
yeah, it says,
Oh, duh, okay,
Yeah.
okay, I'm missing that. That's what I'm missing. Okay, thank you.
Yeah. I was like,
I'm like, this isn't enough information. Oh, that's fine, because EG is also congruent to, thank you. EG is congruent to EH. There you go, okay. Sorry, so what theorem are you gonna need to use for that?
I use.
What, 37?
HL, yeah. Which is not from this section, is it? No. That was one of our older ones, so this is hypotenuse leg. Because it's the same, EF, and if you look, EF and EF, it's the same, it's reflexive.
I don't need
Sarah?
I have a question, like, for all of them.
Yes?
Do you have to say that, the triangles are right triangles?
Yes. You do. So why were we struggling with 7? Did you not see the second given like me?
I don't know, I just feel like, I don't know, it just didn't make sense. Like, I feel like all of the problems were the same in some sort of way, but I got different answers for all of them. Like, I didn't have like similar steps, but they're all the same.
What are all the things?
Like, all the proofs that you gave us, they look like similar, or they have like a similar structure.
You do the same thing for all of them.
Yeah, but like I had different answers and different steps for all of them, so I don't feel like any of my answers are right. But 7 was the most confusing thing.
Okay. I will do all of these on the video, and I will post it on Moto. But I just don't want to waste time in class doing that because we have limited time before the final, and we already have shortened period today. So, I mean, really, it should be the same. These should be very similar to the ones we've been doing, but a couple of you have expressed that you had a harder time with them. I'm not sure why that is, but I will do all of them. I will send it to you on a video so you can see them all, and then if you still have questions tomorrow, we can go over them tomorrow. Is that alright? Mm-hmm. Yes, okay. Because I really do want to talk to you about the next section today, which is on proving corresponding parts of triangles congruent.
You're distracting the class.
And there's not like a theorem or a postulate or even a definition for this. In your book, it just has you write out corresponding parts of congruent triangles are congruent. In high school, I learned it as CPCTC, which stands for corresponding parts of congruent triangles are congruent. So, we've spent 4 sections learning all of the ways to prove that 2 triangles are congruent. And now that we've done that, we will be able to prove that individual angles or individual segments of the congruent triangles are congruent. So, to do that, we use CPCTC. So CPCTC is what you would use as a reason in a proof. It's not a theorem, it's not a postulate, it's not a definition, but it is a reason that can be used in a proof. Okay? So in order to prove that two segments or two angles are congruent, first you identify the two triangles that you're working with, and the two segments or angles should be corresponding parts of those triangles. And then you prove that the triangles are congruent using one of the 8 postulates and theorems that we've learned. And then you can state that the two parts are congruent with the reason CPCTC. So let's review all of the ways that we have learned to prove triangles congruent. I'll wait because a lot of you are still writing. Sorry. Let's do that. Okay, so what are the 4 ways we have to prove triangles congruent for all triangles? What's one? Morgan?
SAS postulate?
Good? Okay, good? Okay. Angle, side angle. Aaron?
Angle, side.
Good? That one's a theorem.
Up here.
Okay? And we also have 4 ways now for right triangles. What's one? Yeah?
L theorem.
Back?
HL postulate.
Aaron?
HA. Actually, I think, is it a postulate or a theorem?
It's a theorem.
Okay.
Maureen?
LA theorem.
Yep. Okay, so we're gonna use all of those still to prove that the triangles are congruent. Morgan?
Can you use the SAS postulate and the SSS postulate and all of those on right triangles, or can you just use like the LL theorem and HL postulate on
You
right
can
triangles?
use any of the ones for all triangles, you can use those for right triangles also. You just go about it in a different way. You just would say that the right angles are congruent and then use the angle instead of saying that they're right triangles. If you wanna use a right triangle one, you have to say they're right triangles. If you wanna use a regular one, you have to say that the right angles are congruent. Alright. So, is everybody up to speed? Yes? So for example, this is number 2 in your book in this section, but I've drawn it for you as well, so you don't necessarily have to get it out, but it's a little bit sloppy. So, given that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, prove that AC is congruent to BC. So, do you see that AC and BC are corresponding sides to triangle AXC and triangle BXC? Yes? Okay. So, first we're going to have to prove that the triangles are congruent. So, and we need to be careful about how we say that to make sure that the corresponding parts are lined up. So what triangles do we have to prove that are congruent first? Sophie? XAC, okay, if you say XAC.
Oh, sorry. XAC and XEC.
And you have to say XBC, right. You could say that other ways, but you need to make sure the corresponding parts are lined up. So in that case, AC and BC are corresponding parts of those triangles. Does everybody see that? Okay, so we have to do that first. So the first part of this will be the same as what we've been doing. So we can start with both givens if you want. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And what else could we say in order to prove these two triangles congruent? Morgan?
XC is congruent to XC, 214 reflexive.
Good. XC is a shared side, so we can use the reflexive. Okay? So we have enough then to say that the triangles are congruent. And what would the reason for that be? Morgan?
Side angle, side postulate.
No. Mac?
Angle, side.
Angle, side,
Oh,
angle, yes.
Because there's 2 angles.
And it is postulate. Okay, so now that we've said that the two triangles are congruent, then we can go ahead and say what we're trying to prove, which is that AC is congruent to BC, and that is because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay? How do you guys feel about that?
Good.
I feel bad rushing you onto this section. I just want to make sure that we're good on information for chapter 4. So, like I said, I will post the answers for last night's or the weekend's homework on Edmodo. And then if you still have questions over it, we'll have time tomorrow to do that. But I do also want you to do, I have another example. What's that? Oh, we have time to do it. Let's do it. Okay. Yeah, alright. So let's do one more. This is number 6, also in your book. So if you don't want to draw it on your paper, you can refer to it in your book later if you want. Given that xy is congruent to zw, no, that's not xy and zw, and angle 1 is congruent to angle 2, prove that xw is congruent to zy. So again, let's say the triangles that we have to prove in order to do this. Who can tell us? Sarah?
Triangle WXC and triangle X. Wait, let me see. YX.
It's actually going to be y triangle y c. Let's see. We have to have w and z in the same place as we have x and y. W is corresponding to y. Yeah. X is corresponding to z. And z is corresponding to x. Okay, we don't have as much time as I thought. Alright, I'm going to shorten what I originally intended for you guys to do. So why don't you just do on page 141 numbers 1 and 3. And then we'll continue talking about that tomorrow.
How many days?